If we say that 1 mole is equal, 1 mole is equal to the relative atomic mass. Atomic and the element of an element. So this is something that we need to know. And then, for example, I want to start by saying that 1 mole of magnesium will be equal to 24 grams. So this relative atomic mass of magnesium, taking an example of this element, this one is equal to 1. So if you want any amount of moles of this magnesium, we know how we are going to weigh in terms of grams. For example, if I want 3 moles of magnesium, now I'm going to write here 3 moles will be equivalent to how many grams? And now, as you can see, this one will be 3 times 24 divided by 1. So you will get an answer of this one. So when you multiply 24 times 3, you get 12, then 6, 7. So we get 72 grams. So 72 grams of magnesium is going to give us, or this one will be equivalent to 3 moles of magnesium now. So we can relate in all ways. That is, we can relate moles with mass in terms of grams, and from there we are able to calculate. Now, if I want, or now 1 mole is equal to 24 grams of magnesium. Now, I would ask myself, what about when I weigh 48 grams? So 48 grams of magnesium will be equal to how many moles? So you cross multiply and you get that 1 mole times 48 grams over 24. So you get 2. This is 2 moles. So remember moles, what we mentioned about moles. This is a quantitative term that represents a certain number of atoms. And we saying this earlier that 1 mole is equivalent to 6.023 times 10 raised to power 23 particles. And in this case, this 1 mole is equivalent to 6.023 times 10 raised to power 23. This particle, this is what we are referring to as atoms of elements and all that. Now, says that if I want to ask myself, in 2 moles of magnesium, how many particles are there? So I can get the number. 2 moles is equal to what? So I will just cross multiply and I get the answer. That is what you are supposed to know. And these particles we see are tiny. They are very tiny particles that we cannot see with our naked eyes. But now, when we are calculating, we are able to use grams and all that to weigh these elements, these compounds. So moles is helping us to do that, to weigh it in terms of grams after we do our calculation based on what now we know, the Avogadro's constant. We are able to know the number of particles. Look at this one is a compound now. Sodium hydroxide. So sodium hydroxide is a compound where we have sodium, oxygen, and hydrogen. So if you want to get the relative atomic mass of this compound, we are going to add sodium, which is 23, because this one is 23 for sodium. That is the relative atomic mass of this, plus of oxygen, which is 6, plus of hydrogen. So we are going to get 40 grams. Now, I want you to look at this. 40 grams This one is now the relative atomic mass of sodium. So we equate this. On this one, we always equate this one to 1 mole. So 1 mole is always, this is something that you need to know. For every compound or element, the relative atomic mass is equivalent to 1 mole. Now this one is 40 grams. So if I want to prepare 2 moles of sodium hydroxide, 2 moles of sodium hydroxide, I'm going to cross multiply here. So I'm going to get 2 times 40 divided by 1. So I'm going to weigh 80 grams. Now when I dissolve these 80 grams in an amount of water, that is mainly a volume of water, I'm going to be adding 2 moles of sodium hydroxide. We would have determined the number of moles, determine number of moles. Determine the number of moles of 13.5 grams per million. Now, what we know here is that 13.5 grams of ammonia, we want to determine the number of moles in this. We know the relative atomic mass of aluminium is equal to 27 grams. Now, this one is always equivalent to 1. So 1 mole is equals to 27 grams. Now, we would ask ourselves, how many moles are there now in 13.5 grams? So we are going to get 1 times 13.5 divided by 27. So automatically this is 0.5 moles. And you can now see this is half of 27. So we get half moles. Relative molecular mass. The relationship between relative molecular mass and moles. So we say that relative molecular mass is when we get the sum of the atoms. The mass of individual masses of atoms. Now when we add or we get the sum, we get now the relative molecular mass. Let me give an example with chlorine. So chlorine, the relative molecular mass will be, we know chlorine is that 5.5. So when we multiply by 2, we are going to get 70 grams. So the relative molecular mass is 70. And now the molar mass for this molecule will be 70 grams per mole. This one is molar mass. So we need to understand how we are going to work with this. Now, if I give another example, for example, water. The sum of individual atoms, hydrogen, which we know is 1 times 2 plus 16. So this is going to be equal to 18 grams. So this one is the molar mass of this molecule. Now, 18 grams per mole will be the molar mass. How many moles are there in, now how many moles are there in let's say 36 grams of water? How many moles are there in 36 grams water? Now what I'm going to do here is that what I know, the molar mass, we have calculated here and we know that it is 18 grams per mole. This one is equivalent to 1 mole. So what about 36? 36 grams. So we are going to cross multiply to get, it is 2. So 2 moles here.